YouTube, Zach Scriven here to talk about how to create a high-performance HMI handbook. So, odds are, since you're on this video, you're an integrator out there, like myself, and you really enjoy creating beautiful screens for your operators to look at and control their system. So, let's talk about some of the mistakes that typical HMI developers make. Right here, the most common and worst, arguably, is the red off, green on pump color status. The number one reason why this is wrong is because red should be reserved for an alarm state. We'll talk about that in a second. And green is actually off in the electrical field. Red would actually be energized. So who's right? Neither. You want to use white for running. It's brighter and it works in really nicely with a grayscale screen. Gray filled in darker for stopped with the text right next to it. Stopped, running. White, gray. Real easy. That leaves open colors for alarms. Here's a tip, and more than likely you aren't doing it to begin with, but it's a good idea. If you're categorizing your alarms, you want to redundantly code them. What I mean by that is you want to code each alarm state with a color and a shape. So each color and shape will both represent a different alarm state. So here we have red square, number 1 for priority 1. I know the color is a little bit messed up on this, but that's actually a yellow triangle for number 2, priority 2. Then we have an orange upside down triangle for priority 3. Notice an easy way to remember is to count the points. Obviously 1 is just a square, 2 has 2 triangle points at the bottom, and then 3 is upside down, so 1, 2, 3. And then 4 is a square turned sideways, and purple. And that's used for diagnostic priority. With these 3 alarm states, you'll just have a lot better alarm notifications for your operators. It'll immediately identify different levels of alarms and prioritize what they should deal with first. Here we have an example of a screen using that redundant coding alarming, and you see we have 8 level 2 alarms, 5 level 3 alarms. Across our analog signals, you can see these 2 have priority 2 alarm states. This one's high, this one happens to be low. The other main thing about creating a high performance HMI is these analog scale indicators. Typically when a number is just displayed, I'll show that right now. When a number is just displayed, the operator has to look at the number for the first step, and the second step is compare that number to a list of numbers as a scale in their mind where that range should be. On an analog sliding indicator, that 2-step process goes to 1 step. You simply look at the scale and immediately the operator can get an idea of where it's operating. And you can see we have a level 2 alarm on the day tank, that just went away, and a level 1 alarm on the other tank. Pump 2 has also a level 1 alarm. So you can see these different alarm coding and the different white and gray pump color usage. Again, red and green, not so good. Can be confusing, like I said, because red means energized in the electrical field, so that could be confusing. White, running, gray, off, and then redundantly coding alarms. And you'll find that your operators will take onto your system much easier, less of a learning curve because it's more simple, easier to read, and overall, just like the title says, more high performance. And that's going to be it for today's topic. We'll be back next week for another control system integration related video. And please subscribe and comment. Thank you, YouTube.